So what is the minimum for 2000? I'm looking at this graph right here, the one up on top. What is the minimum value for that? 14 is the smallest value here. 6. Left-hand side, follow that down on the number line. That would be a 6. That is our smallest or our minimum value. Where would the first quartile Q1 be? That's at 14. That's going to be the left-hand edge of the rectangle. Before we name the median here, one thing that I want to point out. Do you guys remember how we find the first quartile, the lower quartile?
Where the box starts.
It's where it starts, but if I have all of my data, do you remember how I calculate that number? You're absolutely right that it's where the rectangle starts. If all I have is a table full of numbers and they say calculate the 5-number summary, how do we find the lower quartile? How do you find the median? Right in the middle. You take all the numbers, you got to put them in order first, from smallest to largest, and then you cross out until you get to the very middle. That's how we find the median. The way we find the lower quartile is I look at just the smaller half, and I cut it in half again. I want you to think about this for just a second. If I've got a candy bar, and I cut it in half, and then I cut it in half again, how much of the whole candy bar are you going to get if I give you one of those pieces? 1/4. So this right here is 1/4. I feel like I'm writing really messy here. 1/4 or 25% of all of that data, because we took our data and we chopped it into 4 pieces. What is the median here? 20? Yes. Median is 20. From the edge of the rectangle up to the median is our halfway point, right? Well, if this over here is 1/4 or 25% of all the data, how much would this be? 1/4, 25% of all the data. What is our upper quartile? Q3. 22 would be right here. Here's 23.
So 22.5.
Looks like it's right about at 22.5. This would be a whole lot easier if you had it in front of you and you could kind of draw pencil lines with it yourself. It looks like it's in between 22 and 23, so I would call that 22.5. And once again, how much of the data is that goes from the median to that upper quartile? 1/4 or 25% of the data. And then what is our maximum here? It appears to be about what? 27. And to go from that upper quartile to the maximum, last but not least, would be how much of our data? 1/4, 25% of the data. That's really important for us to be able to conceptualize, because if I'm looking at a box plot like this, what this rectangle is showing me, well, if this right here from the edge to the median is 25%, and from the median to the other edge is 25%, how much of my data is being represented inside this rectangle? 50%, that's half of all of my information is right in here. All right, let's list these numbers out for 2010. What is our minimum for 2010? 8. What is the lower quartile, Q1? 11. What is our median? 17. Upper quartile, Q3? 20. And maximum? 28. I know I didn't ask for this on this graph, but does anybody remember from the other day how to calculate the IQR, the interquartile range? Yes, sir.
Don't you add or subtract?
We're going to subtract two numbers.
And then you divide.
When we add and divide, that's finding the mean. That's the average. Good thought, and we will be doing that here in just a moment. How do you find the range? Yes, to find the range, we subtract the minimum from the maximum. If I want just the interquartile range, what am I going to subtract?
First quartile.
We're going to take the first quartile away from what? The upper quartile, the third quartile. So we're going to go with the right-hand side of the rectangle minus the left-hand side of the rectangle. Q3 minus Q1. What would that be for 2000? Again, I know I didn't ask you guys this question, but let's go ahead and do it now. What would my interquartile range be for 2000? 8.5. What about for 2010? 9. Because we're going to do 20 minus 11. And so we get 9 there. So far, so good? Okay. I want you to remember what we talked about, that this, from the minimum to the edge of the rectangle, that's a quarter of all my data. That's 25%. Inside the rectangle, from the edge to the median, that's 25%. 25% and 25%, so that my rectangle represents half of all the data. Keep that in mind. And we're going to go forward in your books to page 295. Page 295. On page 295, you guys have tables. Up on the screen, I made box plots to go with each of those tables. I want you to look at the data that's contained in each of those tables, and I want you to decide which box plot goes with which neighborhood. The table that you have on the left, those are the home prices in neighborhood A. And the table on the left in your book is the home prices in neighborhood B. I want you to decide which box plot goes with which neighborhood. Yes, sir.
This is just a guess, but I think A goes with the top one and B goes with the second.
Tell me why.
Because B has like 475, and that's more like on the other side. And this one has like kind of lower numbers.
All right, so here's what Dalen said. He thinks the top one goes with neighborhood A, and the bottom one goes with neighborhood B. Do you guys agree or disagree? Okay, you're agreeing. Tell me why your reasons are. I heard Dalen's reasons. I'm curious to hear yours.
Neighborhood A has homes in the millions, and neighborhood B doesn't.
Neighborhood A has homes that are in the millions. 4 million, 9 million. Neighborhood B, while they have some expensive homes, they don't have anything that's up in the millions. Neighborhood A is much more spread out. Neighborhood A, they've got some houses that are like right around $150,000 all the way up to $9 million. Looking at just the prices, I would guess that neighborhood A is probably a very diverse neighborhood. You have people that have far different income ranges that are living in the neighborhood together. Neighborhood B, where the home prices are much closer together, the homes are probably going to look about the same size. Maybe the colors are a little different. Maybe they have a little bit more land, better landscaping. But overall, that neighborhood is pretty homogeneous looking. Does that make sense? Dalen, I absolutely agree with the way you had set this out. So there's something else that I noticed when I was looking at these two graphs. They pointed out that we've got these homes in the upper millions. There was something else that I saw with the way the box plots turned out that I thought was very interesting. Do you remember when we talked about that rectangle on a box and whisker plot? How much data fits in between the two sides of that rectangle? 50% of all of the data. So when I'm looking at this right here, this represents half of the homes in neighborhood B. Look how tiny that rectangle is on neighborhood A. It still represents half of all of the home prices. Why is the rectangle so tiny if that's half of all the home prices? Why would it appear so tiny on this graph?
Because not many people have those houses.
Again, this is half of the neighborhood. It's half of all the homes there. It would seem to make sense that it's smaller because there's not as many people, but that's not what our table says. Our table says just as many people live in neighborhood A as live in neighborhood B. So what is it about the way the graph is set up that would mean that that rectangle ended up so little? Yes, sir?
It's because the numbers are drastically higher than the one in neighborhood B.
Yes. When I look at the way my number lines are set up for the two, I had to be able to go far enough out that we could fit that $9 million home on there. If I'm going to fit it on my screen, that means what I'm counting by along my x-axis there, along my number line, those numbers had to be much more spread out, or else I couldn't fit it up on the screen. And so the effect that that had is it took half of the data, that rectangle, and it squished it down into the smaller side. All right. Down on the bottom, mean versus median. What's mean again? How do we calculate the mean? Add them all up and do what with them? Divide. Mean is the average. This is where you add and divide. And what's the median again? Middle number. You got to put them in order first, but then it is the middle number. If all the data looks pretty close to itself, like all the numbers are pretty close together, like in neighborhood B, where we said all of these homes are, some are more expensive than others, but there's no really cheap houses and then super expensive houses. So in neighborhoods like B, if I want to know what a typical or expected home price is, I would find the average or the mean. So the mean is the best measure of center. So what's typical or expected. When the data is all close together. In a neighborhood like A, if I were to calculate the average where we add and then divide, what effect do you think those two really expensive houses are going to have on the average home price? It's going to take it up a lot. But if I'm home shopping and I just look at the average home price for that neighborhood, I might think that there's no way I could afford a home in that neighborhood. Is that true when you look at the actual home prices? No, they have some very affordable homes in that neighborhood. I shouldn't use just the average to decide whether or not I would be interested in looking there, because it's got these two super expensive houses that are way outside of my price range. I could never imagine living in a $9 million home. And so I wouldn't want to use the average or the mean to have a good understanding of what's typical or expected. So the median would be the best way for me to understand what's typical or expected in that neighborhood. The mean is the best measure of center. Sorry, the median is the best measure of center. So what's typical or expected. Running out of room. You guys should be writing this down on the lower half of your page. We call those very, very large values for the home prices outliers. The same thing could be true if I had homes where all the houses were in the millions, and then there was like one house that's $100,000. That would be much, 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 much smaller than the rest of the home prices. That would also be an unexpected value. So if I want to know what's typical or what's expected, and the neighborhood has homes that are all pretty much the same, I'd want to use the mean. If I'm looking at situations where some of the data doesn't seem to fit with the rest of it, then I would want to use the median for what is typical or expected. An outlier is a piece of data that is much larger or much smaller than the rest of the data. All right. So we're going to do some investigating of this kind of data when we have an outlier and when we don't have an outlier. You're going to need to flip forward to page 298. Page 298. So after you have this written down on 295, I want you to flip forward to page 298. And I want you to look at the data there that's in the table. First, I want you to calculate the mean and the median without this highlighted value. So calculate the mean and the median as if that highlighted value there is not there at all. And after you get the mean and the median without that highlighted value, then I want you to do it again. And that second time, I want you to include this highlighted piece of data. I'm going to give you guys a couple minutes to do that. I want you to calculate both the mean, that's where you add them all up and you divide, with and without that highlighted value. And I want you to calculate the median. So you're going to have to put all the numbers in order and cross out until you get to the middle, both with and without that value. I'm going to give you guys about 3-4 minutes to do that. Has anybody found either the mean or the median if we do not include that 20? Mean or the median if we do not include the 20. Yes, sir.
So
No, go ahead.
with the median, if you get 2, don't you add them?
You add and divide by 2. If you get 2 numbers when you cross out to go to the middle.
4.45.
4.45. What about the mean? When you add them all up and divide by, I want to say there's 20 numbers if you don't include that outlier. What the mean is for this data set if I do not include that number that's highlighted in yellow. So if I add up all the numbers except for that highlighted number, and I divide. You should be able to give me the whole thing. Yes. 4.605. What do you notice about these two numbers? What'd you say? They're both 4s. Are they far apart on the 4s or pretty close together? They would both round to 5. Well, one would round to 5, one would round down if we rounded to whole numbers. Are they pretty close together? Yeah. These numbers are pretty close together. Has anybody calculated the mean, the average, including that highlighted number? So now you would have to add one more number on and then divide by 21 instead of dividing by 20 because we've got 21 data values if you include that. What do you get if you add and divide if you include that highlighted number that we left out the first time? 5.338. And what about the median? When you put them all in order and you cross out until you get to the middle? What is this if we include that highlighted value? What'd you say, dear? There's so many numbers. This is actually like calculating this isn't hard from what you're doing on your calculator, but when you have a lot of values, it does get kind of complicated because there's so many numbers to keep track of. This is why we actually use a lot of spreadsheet software like Excel or Google Sheets if we have a lot of data, because it will calculate the mean and the median for us. I mean, this is only 20, 21 pieces of data. Most studies that are conducted, do they have just 20 participants? Normally they have a lot more than that. And so they'll use different types of software to help them calculate things. Not because it's hard, just because it's a lot to keep track of. Does anybody have the median or the middle number here? 4.5. Are these as close together as when we didn't include that 20? These are farther apart. Which numbers had the biggest change? The median without and with, or the mean without and with? I'm looking at now just like these rows. When I look at the median numbers, those two values,
Oh,
the mean changed the most. The mean is much more sensitive to outliers. When I say it's much more sensitive, there's a bigger change with the mean when there's outliers. Our 20 over here would be considered an outlier. Why would it be considered an outlier? It's not that big. It's not like 9 million.
because it's a whole number.
It is a whole number. We've got a couple other whole numbers there too, though. We've got 5 and 8.
It's
And
bigger than all the rest of them.
it's quite a bit bigger than all the rest of them, right? All the other numbers that are there are single-digit numbers. I mean, some of them have decimals, but if I'm looking like from 0 to 9, they all fit in there. Except for this 20 that's way off by itself on the number line. Way over on the right-hand side. This is why if there's an outlier, notice my median still is telling me what's in the middle, what's typical or expected there. The mean, the average, changed much, much more when we included that outlier. All right, one more thing I want to look at with you guys. It's on the next page. Once again, I want you guys to calculate some things for me. So you have a table with 20 values on it there. I want you to find the mean, and I want you to construct a box plot. You have a number line there that goes from 0 to 10. I want you to construct a box plot. What do we need to make a box plot? Think about our bell work. What did I have you identify on the bell work? Minimum, maximum,
Q1, Q3,
Q1, Q3,
mean and median.
and the median. Yes, this is the 5 number summary. You're going to need to find the 5 number summary in order to construct your box plot. I'm going to give you guys about 5 minutes to do this. So you need to calculate the mean, and then you're going to have to put everything in order so that you can find your 5 number summary.
So the repeating numbers, do we put that into?
Any numbers that repeat in value, you would also include. That's a great question. When you put them in order, you would just put them right next to each other, those repeating values. What's the minimum value? What is the minimum or the smallest value? 0.7. Did anybody find the first quartile? Q1. Yep, 1.05 or 1.1 if you round it. The median, the middle value, 2.05. Third quartile, Q3. This one came out to be 2.6, and the maximum was 3.3. The mean of this data was 1.91. Did the data include any outliers? No. What about if we included a data point at 7.5? Would it have outliers? Yes. Up on the screen are the two box plots, both with and without that outlier.